Hi everyone, this is Daisy Merina, Assistant Professor in the Department of Artificial Intelligence and Data Science in Vailtech Multitech Dr. Rangarajan Engineering College. Today we are going to see a video lecture on object detection in the subject Invisible Value Objects. So first we see the overlayer. Object detection, it is a computer vision technique we will use to identify where the object is located in the images or videos. Unlike the image classification, in image classification, we will only label the images. Okay, what are the features in the image? We will label it. But unlike it is, an object detection, we will both identify where the object is located in the image localization as well as the classifications. This is the overall view of the object detection. Next, we will see about the key components of object detection. What are all the key components we are using? These first one is the bounding blocks, classification, localization. Bounding blocks is nothing but it is like a frame which we will use to detect the objects in the location. Okay. Classification means we will assign the labels whether the object is present like a object, car, person, etc. Localization is in that frame where the object is located in the image. These are all the key components. Object detection methods. Object detection methods are classified into two. One is the traditional techniques and another one is the deep learning based approaches. So traditional methods, it was understood before the deep learning. There is nothing, it is a machine learning concept only. So here we are using the two concepts. One is the cascade, that is hard cascade and HV. Next one is the HOG and SVM. HOG is nothing. It is a histogram of oriented gradients and support vector functions. This two method was implemented by the Baila and Jones, and it is known as the Baila-Jones algorithm. So now we see what is hard cascades. It is an algorithm, machine learning algorithm used to identify the object is present or not. And it is different from CNN. In CNN, it will take little bit high time, but in hard cascade, it will easily identify the face in real time quickly. Next, deep learning based methods. So before that we saw what is the traditional based method. Next we are seeing the deep learning based methods. In deep learning we categorize the methods into three. What are the things? First one is the region based method. Next one is the single shot detection method. The next one is the transformer based methods. Before these three we need to know what is CNN, because CNN is the concept we are using in these three. So first we see what is CNN, that is convolutional neural network. So this is the simple CNN architecture. What are all the in this architecture? What are the layers present is first there is the input layer, nothing where we will upload the images. What are all the input we are giving us an images that is present at the input layer. Next one is the convolutional layer. So convolutional layer, the image will be passed into this layer. In this layer, so many filters are there to pre-processing the images. What are the features is necessary? It will be detected in this layer. So after extracting the features, it will be processing through the calculations. What is the calculation processing here? Means the matrix value. So after the first step, we will one matrix value. Okay, so the matrix value is passed to the pooling layer. Why we are going for the pooling layer here? Means because based on the input images, the matrix value will be different. Maybe it will be 3 cross 3, 4 cross 4, whatever it may be. We want one similar, one basic format. For that, we are going for the pooling. In pooling, in this we used to reduce the dimensions of the matrix. The main objective of the pooling is to reduce the dimensions of the matrix. Next one is the dense layer. After reducing the dimensions of the matrix, we need to flattening our matrix. It will be in 2 cross 2. While we are coming to the dense layer, it will become the 1 into 1. That is vectorization. With the help of the vectorization, our matrix will be into flattening. That process will occur in the dense layer. Finally, with the help of the lens layer, we will extract the output whether it is 0 or 1 in binary classification. This is the overall simple CNN architecture. So next we see already we saw in the diagram itself that the CNN is a deep learning model designed for image processing. What are the layers we use to this? One is the convolutional layer, pooling layer, fully connected layer. So convolutional layer is the first one, where first layer where we will extract all the features from the input. So many filters we will be using here. Next one, pooling layer, we are using to reduce the dimension. Then the fully connected layer is nothing. It will be extract the features and the classification whether is 0 or 1 based on the fully connected layer. It processing the conversation. Region-based method. In region-based method, we are using the three methods. One is RCNN, fast RCNN, faster RCNN. So RCNN, from the name itself, it is derived that region-based convolutional neural network. So we will select the object proposed using the selective search only, and we will pass each region through the CNN classification. So it is very slow and computationally it is very expensive. Then fast are seen to improve the time complexity. We are using the ROI polling. There is nothing region of interest polling. It is faster, but still it requires the external region proportional generation. The next one is the fast and RCN. Here we are using network, that is RPN network, region proportional network, which is very efficient for the object classification and the generation. Next one is the single shot detection method. This also comes under the deep learning. In single shot, we are going to see about two. One is the YOLO and another is the SSD. So YOLO is nothing. You only look fast. SSD means single shot multi-box detector. So you only take once. What is the main concept in that? Means it will divide the image into small stuff and predicts bounding boxes and class probabilities in a single pass. It is extremely fast and it is very suitable for the real-time applications. In the later slide, we will see in detail about the Euro, what is the architecture. In the upcoming slide, we will see in detail. So many versions are there in Euro. It starts with version 1 and now it comes to V8, that is version 8. The next one is the single shot detection method. That is single shot multi-box detector. That is the abbreviation for that. It detects the objects with the help of the multiple scale for using the different feature maps. It is faster than the faster RCN, but the accuracy is very less in this. So the third one is the transformer based methods. So this is the latest advancement. Now in this we are going to see about the two. One is digital and the other one is vision transformers. So detection transformer that is trending now. So uses the transformer for object detection without requiring any anchor boxes. No region boundary boxes is required over here. It eliminates the need for the RPN. So the RPN concept will be eliminated over here. The next one is the vision transformer. So it uses self-attention mechanism for detecting and classifying the objects. It is useful for classifying for the large scale data sets. Based on the three methods in deep learning, we saw three methods. What are they? One is the region based, next one is the single shot detection, next one is the transformation. So based on this three, which model is best, right? Object detection. So for high accuracy, we can use the faster RCN or better. Then for real-time detection, we have to use the YOLO and SSD. For lightweight applications, that we see the biological algorithm, that is the hard cascades and the histogram of gradient and support pattern vision are useful. Next, we will see in detail about the YOLO. You only live once. Okay. It is the state of the art of the real-time object detection system. It was developed by Joseph Redmond et al. So unlike the traditional method, YOLO processes the image in a single pass. Why choose YOLO? Okay, based on these three, 4 points, we have to choose this YOLO. Why means the accuracy is very high based on the real-time performance. The next one, the speed. Single pass architecture for speed. No need of the multi-layer architectures. One single pass is enough. The next one is in-bringing capability and works well on with both the large and small objects. These are all the 4 plus. Why we want to choose the YOLO? How YOLO works? Okay. So it divides the images into a grid. Each grid cell predicts bounding boxes in the class probability. It uses only a single neural network for feature extraction and classification. These are all the main three key points how the URL works. So first it will divide the images into a grid. Next, each one grid cell will be correct by the bounding boxes. In that bounding boxes, we will use the probability status whether the object is in that image or in that region or not. Okay, then we are using a single neural network. Only one pass. We are using the image in the one layer. Okay, for feature extraction and classification. YOLO architecture overview. This is the overview of the YOLO architecture. Similar to the CNN, here also we are using the CNN layers. In that layer, we will be using the same process, the pooling layer, the dense layer, the output. Okay, that convolutional layer will be, we are using based on the desire of us, we can use how many convolution layers we want, we can use. And last, we will use the fully connected layer. Okay, next one we are going to see about the architecture overview. So what are all the blocks we are used in the architecture? Okay, first we know that is input processing. That is nothing but it is a pre-processing the images. So in input processing the images resized and normalized. The next one is feature extraction. So feature extraction is the backbone CNN extract feature. So based on the CNN only, we will extract all the wanted features. Next, the main concept of YOLO is grid division. So the image is divided into a number of grids, that is X into X or Y into Y. The next one is the prediction. We will using the bounding boxes. In the bounding boxes, we want to predict whether the value is 0 or 1. That is the bounding box prediction. Each cursor predicts multiple bounding boxes. Okay. So the next one is the confidence score calculations. So confidentially, whether the object is present in that frame or not. That is the confidence score calculation probability that a bounding box contains an object or not. The next one is the NMS, nothing non-maximum suppression. So it filters overlapping boxes to keep the most relevant ones. So here what will happen is it will filter the overlapping images. Okay, inside the frame, so many frame boxes, bounding boxes will be coming. So what are all the boxes are overlapping? It will remove one key only what are all the frames maps are similar to the images. Okay. The next one is the final output. So we will classify the label whether it is 0 or 1 based on the bounding box coordinates. Okay, this is the YOLO architecture overview. These are all the 7 basic steps we are using in the YOLO. Okay, recapping one of the things we saw means first one is the input processing. Nothing, it is the image is resized and normalized in the first step. Next, feature extraction. How we saw in the CNN, how the features are extracting, similar to the CNN, the features will be extracts. The next one is the grid division. The main concept of the YOLO is the grid only. So the image will be divided into S into X grid. The next one is the bounding box prediction. So we have to predict whether the bounding boxes or not. Each grid cell predicts multiple bounding boxes. The next one is the confidence score calculation, probability, whether the object is present or not. So based on the probability, we will classify. The next one is the NMS, non-maximum suppression. It filters overlapping boxes to keep the Most relevant, we finally will get the output based on the label classes. Next, we will see about the evolution of YOLO versions. So, YOLO version 1 was introduced in the year 2016 model. To improve the accuracy, the version 2 and version 3 are introduced. Then the updated version 4 and version 5 is updated for optimized for real-time applications. The next one is the version 7 and version 8. Here we are using some approaches, state-of-the-art implements of the transformer-based approaches. Now we will see about the applications of YOLO in real time, the YOLO algorithm works and what are all the various feeds. First one is the autonomous driving to direct the pedestrians, vehicles, and traffic light signals in the real time. The next one is the security and surveillance for crowd control monitoring and objects in the video feeds. With that, we can identify the suspicious activities. What are the different activities happening in the environment? We can identify based on the YOLO algorithm. Next one is the healthcare and medical range. So basically it plays a major role in the healthcare. It directs the tumors and anomalies in medical scans with scanning the images. Next one is the customer analytics. That is the smart data tracks the customer movement and detects the shelf inventory levels. Based on the customer's review, we will use to update the data. The next one is the augmented reality. It enables real-time object tracking for the experiences. Implementing YOLO. For implementing the YOLO, what are all the basic things we need? That is the framework. So in framework, what are all the framework? OpenCV, PyTorch, TensorFlow. It is used for deploying YOLO in real-time applications. The next one is the pre-trained models available. Whatever the pre-trained models available is Crypto Pascal VOC. It helps to detect the object in real time without any need of training. The next one is the custom training with labeled data sets. In custom training enables YOLO to detect domain-specific objects. So many domains are there. There is the industrial, medical field, then the road and safety, transport, like that. So many fields are there. In that particularly, we have to give the custom training for medical images. These are all the training. For industrial parts, these are all the training. And for the transportation, these are all the training like that. We have to custom the training with the label data sets and it works well. Challenges and features of YOLO. What are the challenges means to handle and small object detection is very difficult in the YOLO. Okay, then to reduce the false positives, to reduce the false predictions is also the main challenges. And what is the future of YOLO? We will see means integrating YOLO with the some other models, the transformer models or some other models, we can reach the accuracy level. These are all the challenges and features of YOLO. Advanced YOLO techniques. So YOLO with attention mechanisms. We can use some mechanisms with YOLO. It improves object detection by focusing on important areas in an image used with the autonomous driving. The next one is the tiny YOLO edge devices. It optimizes lightweight model for real-time detection of mobile and IoT devices, which is smart CCTVs. There is a surveillance cameras. Then combining YOLO with semantic segmentation enhances understanding of the object boundaries and it improves the precision. Okay, the precision level will be improve if we are going with the semantic segmentation. These are all the advanced YOLO techniques. So mainly three one. One is the attention mechanisms. Then we are using the edge devices for tiny YOLO. Then next we are using the segmentation mechanism for this YOLO. Future of object detection. So in future, object detection will looms and what are all the areas? Okay, integration with the AI driven automation. In automation, it plays a major role. In advances in real-time video analytics. The next one is the merging with AI-based scene understanding. These are all the three features of the object detection, not only three, so many are there. Among them, these are all the three features. The Sustainable Development Goals. Simply, we will give the acronym as SDG. It aims to end the poverty, protect the planet, and ensure prosperity for all the people. There are 17 goals which are adopted by the United Nations member states in the year 2015. The 17 SDG goals are: the first one is the no poverty, the second one is the zero hunger, third one is the good health and well-being, fourth one is the quality education, fifth one is the gender equality, sixth one is the clean water and sanitation, seventh one affordable and clean energy, eighth one is decent work and economic growth, ninth one is industry, innovation and infrastructure, 10th one is reduced inequalities, 11th one sustainable cities and communities, 12th one responsible consumption and production, 13th one climate action, 14th life below water, 15th life on land, 16th peace, justice and strong institution, 17th partnership for the goals. These are all the 17 goals. So among the 17 SDG goals, we will see about the 3 SDG goals matched for the YOLO algorithm. So SDG goal 3, that is good health and well-being. So with the help of the image analysis in medical imaging, it plays a major role. In medical imaging, with the help of the analyzing the scan reports or MRI reports, whatever it may be, we will be easily detect the disease. So it plays a major role in the SDG 3. Next, it plays a major role in SDG 9. That is industry, innovation, and infrastructure. So nowadays, in moreover all the places, it becomes a smart cities. So based on the smart cities, we are using here also we are using the analysis technique, image and analysis, video analysis technique. We are using so many algorithms over here. Not only in the smart cities, in automated industries also we are using the same with the help of the surveillance systems, automatic sensor detection. So many various examples are available in that. The next major goal is SDG 11, that is sustainable cities and communities. It plays a vital role in the traffic management and safety enhancement. In traffic management, to avoid the accidents, so many algorithms are designed to predict the algorithm. In the Majorly in the railways, there are so many automated detected alarm is there to avoid the pedestrian, to give the signal to the pedestrians the train is passing on the way. And it is also used in designing the safety enhancement. So in the image analysis, these are all the three goals with the help of the YOLO we can use to protect our environment in a safer manner. This is for YOLO and video analysis. So in video analysis, what are all the sustainable development goals we can cover means SDG 13, that is climate action. So in climate action, wildlife monitoring and environmental protection with the help of based on the climate, we can protect our environment by giving awareness to all. The next SDG is 16, peace, justice, and strong institutions to prevent the crime with the help of the analyzing the video. We can give justice to the environment. The next SDG is 17, partnership for the goals. We can give the partnership based on the collaboration in AI and data science with the video analysis. So these are all the three SDG we can cover with the help of the video analysis. So a small recap, what are all the topics? We saw object detection, what is object detection? Then we see what are all the methods in object detection. One is the traditional based, the next one is the deep learning. In deep learning, we saw the three methods. One is the region based, the next one is the transformer, the next one is the single shot detection. Then we saw about the YOLO algorithm. Then we look into the SDG goals. What is SDG goals? What is the main aim of the SDG goals? By studying image and video analytics, what are all the facilities we can do to the environment also? Thank you.